In this video, I'm going to show you how to draw a tangent line. I'm going to show you how to draw this tangent line for a course graph in Desmos. So, for example, if I press play, it will draw the tangent line for the course graph. Okay, so let me pause this, jump back to this. So we've got to come up with the equation for this tangent line. Well, this is a straight line, so it's going to be of the form y equals mx plus c. Our job is to work out the gradient and the intercept. Well, if you want to know the gradient, what you do is you differentiate this. So when you differentiate this, it will be dy by dx equals negative sine of x. So we've done this before. Look at the proof. I've done a video on this already. So when you differentiate cos, it will give you minus sine of x. So now this you can think of it as being like the gradient formula for anywhere on this cosine graph. You can work out the gradient anywhere on this cosine graph. But the thing is, you want to know the gradient right at here. So if you want to know the gradient right at here, then you've got to put a into the x here. So the gradient there would be, the gradient right here, the gradient right there would be minus sine, well, put the a in the x here. So that would be minus sine of a. So that's your gradient right here, minus sine of a. So let's put this into the m here. So our equation for the tangent line is, so far, y equals minus sine x, minus sine a. So that's your gradient, minus sine a. That's your gradient here. That's your gradient here, and then you've got your x. But when you write it like this, it doesn't look right, because when people read this, they will visualize it like this. So instead, write it as this. Instead, write it as minus x sine a. So write it like this. So when people look at this, they will know that this is one block and this is another block. Well, anyway, you've got your plus c. You've got your plus c. So now this is now our equation for the tangent line so far. We need to work out the intercept. So to work out the intercept, we need one particular point on this tangent line. Well, we've got one particular point. It's right here. So the coordinates here would be a comma, hang on, let me get rid of the gradient. The coordinates here would be a comma, well, if you want to know the height of this thing, put this into the equation, and then it will jump to the height. So the coordinates here would be cos a. Okay, so this is your x, this is your y coordinate. So now we can put this into the y, we can put this into the x, and then work backwards to find c, because we need to find the intercept. The intercept here is right here, but we don't know where this is. So let's work out c. So the next step would be, hang on. Well, the next step would be put this into the y. So that would be cos a equals, and then put this into the x. So that would be minus a sine a, and then you've got your plus c. So to get c on its own, add this block to both sides. So that would be cos a plus a sine a equals c. So now we can put this into here, and then this thing here would then become y equals minus x sine a, and then your intercept is this thing here, plus cos a plus a sine a. So now just jump to Desmos and draw the whole thing. So jumping to Desmos, new graph, and then it would be draw your cos graph, cos of x. So that's your cos graph, and then add your particle. The particle would be a comma cos A, close it off, and add our slider, and we want it to range from negative 2 pi to positive 2 pi. And then now punch in the equation of the tangent line, which was this thing here. So minus x sine A minus x sine A, and then it was plus I think it was cos A plus A sine A. So so now check it. As you slide A, it will work out its gradient and its intercept, and then from that it will draw the tangent line. Okay.